Alright, it's time to get started. Here we go. Interesting music. Makes me remember a little to Shenzhen's EO. Okay, so we was in the middle of emulating cartridges. And this is not the right chapter. We're on chapter 5. So we have been working into this part of the code. We have a file reader running, but it is not finding exactly what we expected in first place. But let's see, let's move on before trying to find out what we are doing wrong. And I will probably follow the suggestion from someone in the last time to make a restore from the ROMs. So I just did not want to do it yet, but that could be something that we do today. We want cover support for this. How hard is NES version 2? Overview. So we have block diagram NES. So we have position 0, size 16 header, and the header is 4 is the magic, length of the program and character from F6 and F7, which takes this. So F6 is lower map, F7 is upper map. And bit type big bit endian, 4 screen, trainer, has battery RAM, mirroring, and this one has P4 is format. I see no information about format in here. So it's very awesome how it's written. So it has exactly the same information explained in a different way. So, how is music? I hope it is not too high. No, I had that frame drop. I hope it is not going too bad. Okay, let's try to move on. So it says F9. It has a reserved byte and 1 bit for TV system. I suppose it is the NTSS or PAW, maybe. Header F10, blah blah blah. We have 1 reserved bit. Boost conflict, program RAM, reserved, TV system. So there are 2 bits from 2 different bytes for that as well. Wow, music is too high in my ear. I almost have to mute it because I cannot read properly otherwise. Anyway, the part that we have been reading from the header seems to match. So I see there are, oh, it is 5. It's from 11 to 16. $50 actually reserved for something. Anyway, so this one is interesting. We have a shamil that makes the reading of the file. So can we use that to understand better? Or we could try to see an implementation in C++. Do we have a Python? Go, Graphics, Java, JavaScript, Lua, NIM, Perl, PHP, Python. We have a Python implementation. So it is reading a structure. Oh, it is. It uses the shamil file, right? So let's see. Read the raw header, byte input output, set reader header, blah blah blah. Ft trainer. Program room, chart room. So it takes the size multiplied by this number. So maybe is this the same value as the formula that we have been making? Let's take a look to that. I thought that Godot was open. Maybe I accidentally closed it. Okay. So let's see our NES room. So we have 124 times 16. One 24 times 16, and that is 16,384. 16,384. Yep. And 124 times 8, 192. Okay, so our math was correct, and that is tranquilent. Play choice, blah blah blah. I don't think this helps, honestly, because it makes use of this kaitai struct for reading inside. This is the class INES kaitai struct. No idea what the parent or root are. Here it seems to take a byte stream. Okay, so it seems like the end of the file could be a the name of the ROM in ASCII code. So let's start figuring out if that assumption could be correct. Let's say a ROM. Oh, I don't have an actual ROM file. I should have the Snake game, though. This is in the ROM Snake. And what if I open it with code? We open it as a text file and see how it ends. Okay, it does not seem to have the name built in at the end. Okay, we'll forget about that. So we have header and okay, it is using a header class defined in here. So it is making the assertion if the magic bytes do not match. Then it is reading the length of the program. Then it is reading F6 and creating the F6. I wonder why it is they decided to call it F. But it is still an interesting implementation. I think this could improve my code. I having stuff on classes that reads the byte. Anyway. Horizontal vertical. So it reads mirroring. F7 reads the upper matter, reads 4 bits. Okay, reading bits at a time. I never expected input output could do that. System. Yeah, NTSC or VAL. It's the meaning of those. So we could try. No, I don't really want to. But we could try to convert these to GdScript using GTAI, but I don't really want to because I don't like the way it's being used. I would prefer to make my own structure of how stuff happens. So let's take a look to the actual values that we're reading and making sure we are reading the right stuff from it. So we are getting from PRAW byte index 1 and 2 are 6 and 7. 6 is a 1 and 7 is 0 apparently. So mapper should be 0 from what I see here. Yes. INES should be, I think, 0. Full screen is 0. Vertical mirroring is 1, I think. It's true, yes. Indeed. So we have vertical mirroring. The ROM size is 32,788. It does have a trainer? No, it doesn't. Program starts at 16. Chat room starts at 32,784, which happens to be the size of the entire array, so it has no char as expected. So the loading seems to be doing its work. So it is passing our initial test right now. Let's keep this in mind just for later, but let's find where we got lost. So we wrote the code to read the data from file, and now the idea was connected to the ROM bus. So the ROM was going to take a virtual RAM of the size, I don't know why exactly this size. Like in example, the ROM that I had was, okay, yeah, I see why. So this is the actual RAM, and the ROM is read-only memory, and when reading, it would take the ROM depending on the range of the values. Okay. So let's see our NES ROM, NES memory class. So now we are going to have a ROM of type NES ROM, and we need it to be set before trying to read the values. Let's do this a manual memory, but do we have a reset function into memory? I think we don't. Okay, we do have a reset memory, so we can override the reset function. Oops, wrong script. Where is the script? Okay, here. Let's close a couple of files. And let's open this NES ROM and NES memory. Okay, so now I will override reset, will call super, so the upper level is called, and also will set ROM to null. So every time reset is called, the ROM will be cleared, and we'll also create a soft reset that clears clears the memory, but does not clear the ROM. So, do I want to create a function in here? Func soft reset, just a virtual function. Just to keep the interface clean. So the soft reset is going to gather hard reset of the parent class in this case. So it will clear the content of memory without clearing the ROM. And that is basically resetting the game without removing the cartridge. Okay. So now we have the ROM, and we have to look at how reading the memory is done. So now, when reading this range, is okay. RAM goes from 0 to 1 FFFF, and PPU goes from 2000 to 4000. So now let's make ROM memory, and ROM memory mirrors end. Okay, so now if address bigger or equal to ROM memory and address less equal to ROM memory mirrors end, we are going to read the value from the ROM. Program ROM, right? Read program ROM. Okay, it is making a function, local function, so we can do that. Read ROM. Oh, damn. And we pass address, I guess. Do I return? Just return. Let's see. Let's put this on this side and Godot in the other side and hide the files and hide this column and see side by side. So let's make the same condition for writing, and let's make a push warning same as before with this message. Should probably be an assertion instead, but I want to avoid it for now at least. address value. So I never defined the value, so this is from 8000 to FFFF. Okay. Okay, read from and should probably be internal. Oh, let's see this. So bar mirror down address, emit observer, and wait a second. No. Right, so this is prog rom byte. Let's name it like that. So let's put it in here. Let's put it in here for the emit observer. And this function doesn't exist, but doesn't matter, and we can return the value. Now we should have to define this function. Let's do it right below. Function read program ROM, and we are going to have an address integer. It will return an integer. And what does this do? So it will subtract 8000. So let's do address less equal ROM memory. It should be probably be called ROM memory start. ROM memory ends. Okay. And this one replace ROM memory start. Let's replace a couple of usages. Okay, what error was that? Okay, this is an integer and it equals to 0x. Okay, awesome. Why not? I suppose I did something wrong. Okay. Right, we are not returning anything yet. If program from len equals 4000. Oh, this is a strange condition. Could the len be exactly 4000? Let's see if there is an explanation here. We finally need to map the space 8000 to 10,000 to cartridge program ROM space. 1 kbit program ROM size might be 16 KB or 32 KB because this mapped region is 32 KB of addressable space. The upper 16 KB needs to be mapped to the lower 18 KB if a game has only 16 KB of program ROM. Okay, so I guess that means it is forced to have empty space. Yes, because it has only 1 or 2 banks of ROM, I assume. So I assume this is if the length is less or equal. If ROM dot what is the PRG ROM dot size less or equal to this. So one thing we should do is assert ROM is not null and ROM dot loading error equals NES ROM dot loading error dot OK. Invalid ROM file loaded. If not, address bigger or equal to 0x4000, then address, let's make a wrap for address. Okay, this is all the same. Okay, from PRG from and the address. Okay, seems about right. I am having some trouble to find the right to type correctly. Sorry about that. You can download your first dump file. You will need to modify main method to load binary from a file. Spoiler alert, blah blah blah. So this is the thing. I think what we should do to make this, to call this chapter finished, is being able to execute the snake game from that file, and for that we are going to duplicate most of the snake tests. So I will select everything here and let's go to the NES room test, and let's start by pasting the code below ready, and let's see what we want to change. This one is going to extend controlling instead of node. We don't need the game code. Get away. Let's make a new class. This is going to be NES Snake CPU. So we are going to keep this stuff. We are keeping the no operation code, no op per frame. This will be the same. For memory, we are going to create an NES memory instead, and doesn't take any size. And we are going to place the no op as well. Now we are going, instead of loading the program this way, let's load the ROM by saying memory.rom equal, and let's see this. So we can put this part that wasn't ready inside of this initialization. So we are going to load the snake ROM. We are going to set it to the memory. So let's rename this to snake ROM. Okay. Blah 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 blah. So now we want to use the NES Snake CPU. We create a screen observer for the same region, and we don't want to load the game code. We can choose run, I guess, because loading is happening directly on the memory. So can we, I think we are ready to run this. We can try it. Hey, Capsilla! So I have not seen you in here yet. So have you seen this stream sometime? It's long time since we don't talk, bro. So last time I saw you, you was playing Mega Man X4 or something like that. And yeah, I am programming in Godot, making an NES emulator. Mariana, it's been a very long time. I hope that you are doing great. Yes, I am. So I am making an emulator for, oops. Right, so now I need to copy this file and paste it here, make it the root. Yes, but I also want to set this script. Let's make it sure it is set. Now let's rename it, and let's make this one into a window the same as the other. Change type to a window, and let's copy properties and paste them in this other node. So now we should have the snake game running inside a window. Okay. Oh, it's just the the breakpoint. Okay. Something did go wrong. What did we do wrong? I suppose I did not reset, maybe that. So I call it run. What does run do? So let's see what read is doing here. So it is going to refresh the screen. It is getting a slice of memory. Wait a second. It did not read any memory. So let's redo that. And let's see what is the memory. CPU. Oh, right. Slice may not do what we expect it to be. So begin is 215. So begin is begin maintain it the same, and oh, I don't like that. So it is being entirely cropped. And why is that? Okay, it is making exactly the same. What was end? End was... Okay, let's rerun that. Sorry, I am getting lost. Okay, end was 1536. So begin kind of remains. RAM mirrors end, and that is 1FFF. Let's check our calculator. 1FFF, and it is 8000. So the value that we have is 1536. 1536. Oh, I see the bug. So we have begin equals begin, begin equals begin, and here it says end equals begin to be equals end. And otherwise it was copying the value of begin. So let's restart that. And let's see if at least we have a black screen. Yes, it's working cool. So now, what is run doing? Let's see that. Let's enter. It's running is set to true. It will await to execute instruction. It should make the same stuff as before. It's going to root an opcode. Opcode is 0. What is run and counter value? What? Run counter is not set. Okay. So I suppose we have to call reset before run because the register is not set. So in our ROM test, yes, before calling run, we want to call CPU.reset, and reset should set the program counter. Wait a second. Yes, to whatever is inside of this value. So the question is this value gonna be populated correctly? There is only one way to check, right? So now what is the program counter value? This is not correct, then we have to fix the memory. Register program counter. Here we go. Okay, things like we have value now. And the game is running. Believe it or not, we are running Snake from a ROM file. Hey, Cricket! How are you, my boy? So as you can see, Emulator is moving. Been lurking, hope the progress is going good. Ah, stupid. Stupid. Typical corner issue. Okay, I am surprised that it did not need much more fixes than that to make the game run, loading it from the ROM file. So I am seeing that we have an incredibly lot of warnings and errors. So I would like to see what they are about. So if I press escape, this should quit. No, it doesn't. I will just crash against myself. That would be fun. Yay, game over. So what are bugs about? Okay, it is ignoring memory address. Oh right, this is elif. That could be it. So do we have errors now? Okay, no error so far. Let's see once we collect the apple. Okay, all directional sword. I feel like I am on my Nokia again. Why is the stream looking bad? I had some frame drop when I started streaming. So cool. So, want to see the game running faster? What do you say? What if we change the speed of the game to twice as fast by saying it will execute 40 no-op per frame? Here we go! We can make it faster. Bum, 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 bum. Let's see something weird, like 10 times faster. Probably impossible. Yes. Yeah, it's too much. And what about 3 times faster? Yeah, that already looks fun. Oh, I lost. That was a fun speed. Let's make it maybe 80. No, 80, not 800. This looks like a reasonable speed. Mhm. Okay, let's keep this value. And we could also change the 6502 game to have the same speed. Okay, let's commit this and move on. Git status, git add import, git not code, git good. Okay, awesome. So I added a virtual function, and in the NES memory added the ROM mapping and implemented reset. Adding reading, added writing, actually avoiding writing. Fixed this bug, important bug to fix. And this is basically make the snake room, the snake game load from file and start it. Yes, yes. Git commit. In theory, I could play other games, but the restriction is they need to use the same rendering method as the snake game. So that is not something we can decide, right? So unless there is an NES around Doom file that makes the same assumptions, then it will not be possible. So let's commit this. Test NES room now loads and plays the NES snake.net game. From Doom 5. There we go. And I think this closes. No, I will not say anything because I did not create an issue. But stupid. We're pushing this and considering emulating cartridge done. And the next task is going to be load and process the test ROMs, which is in our tutorial the next chapter, chapter 5.1, which is this chapter, right before starting doing things with the renderer. Okay, moving on. The NES dev community has created large suites of tests that can be used to check our emulator. They cover pretty much every aspect of the console, including weird and notable bugs that were embedded in the platform. We will start with the most basic test covering main CPU features, instruction set, memory access, CPU cycles. The INES file of the test is located here, and let's download it. Did it download? Menu tab. Notify save as. Okay. Let's put it in the test. NES room test. Okay, I don't want to discard it, I want to keep it. And we also want an execution log accompanies the text showing what execution should look like. So let's also download the test. Save as NES test log, save. The goal is to generate a similar execution log for the CPU while running a program. So when it runs every execution, it should print a line that matches with this part. So basically we are going to create a function that generates one line per instruction and compare it to the same log file. But to do that, or before doing that, let's keep reading. For now, we can ignore the last column and focus on the first 5. So we have program counter, CPU, opcode in assembly language. So we are going to disassemble each instruction. We have an add separator apparently. I don't know why. Only this line has it. So we have 80 plus x equals real address. Memory value real address. So 80 is the value of the byte, I assume. X was the value of 200 was the value of x, maybe. No, it's not the value of x. It is the value of what was read. Wonder if it is on hex or not, because is no, it's not. Okay, so there was something on X apparently. So I don't know if this is in hex. For now, we can ignore the last column and focus on the first 5. The fourth column at 80 equals 200 equals 0 is somewhat interesting. The first number is the actual memory reference that we get if we apply the offset of the requesting address. 0x000E1 is using the indirect X addressing mode, and the offset is defined by register X. The second number is a 2-byte target address fetched from 8081. Okay. In this case, it is 0002. Okay. I get it. So it is the value that was on memory without doing the indirection, I suppose. And it's also big endian, not little endian, from what I assume. Wait a second. No, it is little endian. The third number is content address. Okay. So this is little endian because the address in 80 was 0 and the address in 81 was 2, and it is being flipped around. Okay. So I suppose that X was indeed a 0. We already have a place to intercept the CPU execution. So let's make a new scene for testing this. We're going to make it in the same room folder. Let's make a new scene. And let's call this one NES room unit test .tscn. It's going to be a node. Let's create a script for it. So let's take a peek to how we created the snake room for NES. What I want from this is the header, just in case I need it, the init, about to execute, and probably nothing else. So the reason why we are making a new class is because we don't need a white frame. It's because we want to override about to execute instruction. We're going to make something different here. And we don't want to override no operation. And we want to rename snake room something different. I learned last stream that if you press Ctrl D many times, you can select all occurrences of the word, allowing you to rename it all at the same time. So I can name this unit test ROM. And now I can change this file to whatever is the real name of the file. So let's see in the file manager, and I will copy the file name nesttest and we'll name it nesttest.net. Actually, let's create a a constant unit test path equals this. It's of type string and choose path. Unit test file name string equal, and we are going to put only the name. Const unit test extension is going to be equal to NES const unit test log extension log. So we are going to have all of this is internal constant. Const unit test ROM file is going to be the path plus the file name plus a little dot and plus the extension. And the log file is going to be the path plus the file name plus a little dot and the log extension. Okay, so now we can use this instead of something weird, and if we ever change anything we only need to change one of these and not everything. That is more or less the idea. So what is the tutorial doing with about to execute instruction? Will we emit a signal with the recopilation of the last instruction? So run with callback opcode callback third. All we need to do is create a callback function that will trace the CPU state. So it just prints and makes a trace of the CPU. Okay, that sounds reliable. So print trace self. Now let's just call it trace. There is no need to pass self, it is a local function. Func trace. I personally think I would prefer to emit a signal instead of printing, and I will probably do it later, because that way we can take the string and compare it to the content of the file. It is vital to get execution log format precisely like the one used in the provided log. Following tests can help you get it right. So test trace format, blah blah blah. So we are not being given with the code, are we? I will ignore that test. Now it's time to compare our execution to golden standard. Oh, it is making a diff instead of making it part. Okay, so let's just see the content of the log file. So talking about that, is the log file? Yes, the log file is being imported and it's visible, and I don't see. Okay, so it makes this only when there is indirection, apparently. At 80, at 82. Okay, so 82 is already the value plus x. So everything is put in an equal. Okay, let's start small, right? So we start with program counter. Out is a start string. Out plus equals, and I need to check what was my format for printing hex values. Python format hex value. Okay, this is the one I wanted. Okay, %x is the format. So it is %ox maybe. And maybe 4x for 4 digits. Let's see. And program counter value, breakpoint, and let's start this scene and see what happens. No, this is not the scene. This is the scene. Did not pause, did it? Right, because I never started the game. So the other part of the code that I care was the ready function. So I want the CPU and I want the ready function, And I think this is all. So I don't care about the screen observer. I will rename this CPU. We don't care of input. We don't care of screen. We just want to reset and run the CPU. Play. No, wrong scene. Okay. So it is printing the function instead of trying to call it smart. So now we got the breakpoint. And what did it print? Okay, nothing. We want to see the content. Okay, C004, which matches our file, but it is in lowercase and we want it in uppercase. But I think we can make out the entire line uppercase at the end, so let's not care about that. So 1, 2 spaces. Next is the opcode. I think we can see run and we can see how it gets the opcode. I think here. Wait, this is not the function, this is the function. We're going to read the opcode and we are going to get the opcode. I think we also have that part in this line, so we can get the instruction. Bar opcode bar instruction. Assert instruction. And now we can print some more values, like let's see our log file. So we have the opcode value and whatever are the next byte of program value. So we want to print two arguments, one space, right? Yes, one space. And this is going to be instruction dot what is it? It's code. Instruction code. If instruction plus instruction size, yes, size bigger than 1, out is going to be, we're going to print another byte, reading it from memory, and it is going to be program counter value plus 1. else we are going to print 3 spaces instead. And now next is the other byte. If the size is bigger than 2, we are going to print the next value plus 2, otherwise more blank spaces. So now is the hard part. So we did not have stored, we have not stored the addressing mode. So this is bad, because we don't have the addressing mode. We have no way to make this assembly, so we may need to do some refactoring. So let's see if it's vital to get log format precisely like the one you set in the provided log. Following this, blah blah blah. DA, blah blah blah. LDF. Now it's time to compare our execution. You can use any diff tool you would like, but because our NES doesn't support CPU clock cycles yet, it makes sense to remove the last column in the provided log. If everything is okay, the first mismatch should look like this. And why is that? I don't know how to read this. Okay, so it's 38, 9. Right, the no oak. In extension, everything that our emulation has produced should exactly match the golden star dance up to line this. If anything is off before the line, we have a mistake in our CPU implementation and it needs to be fixed. But that doesn't explain why our program got terminated. Why didn't we get perfect match after this line? The program has failed at no operation. It looks like our CPU doesn't know how to interpret the opcode 04. Here is the bad news. There are about 110 unofficial CPU instructions. Most of the real NES games use them a lot. For us to move on, we need to implement them all. The specs can be found here. Blah blah blah. Remember how to draw an O? The testing room should drive your progress. In the end, the CPU should support 256 instructions. Considering that 1 byte for the recuperation code, we have exhausted all possible values. Finally, the first mismatch should happen on this line. Okay. Okay, so we have a couple issues. So we are going to need to make some changes to this code. Let's make our opcode doesn't have a node information for everything. So we are going to need to store bar register one and two needed. I think it should not need two. What is the base class for register? Register 8 bits and 16 bits. Okay, we can use register 8 bits, I guess, but it is on the CPU dot register 8 bits, right? So for now, let's name it register. Actually, we could use string name. Pa-pa-pum. Pa-pa-pum. Addressing mode equals to CPU addressing mode. What was it? So the thing is, this opcode would be specific. Let's make it an integer. And -1 by default, meaning no addressing mode. So we are going to store the register name and the addressing mode as integer. So p register equals string name p addressing mode equals -1. So register equals p register p addressing mode equals p addressing mode. Yes, it was addressing mode, not p addressing mode. I suppose this is getting boring. Sorry about that. But it's part of the task. Let's make a new line here. So now the opcode needs 2 extra arguments that are empty by default. the thing is, when we register stuff, we are going to need to keep the name. So register 8 bits is going to have a name on it, type string name. And we are going to need to register them on init. Name, pname, string name, assert pname is not equal to an empty string name. So we are going to make sure we are always setting the string name. So now we can replace this AXY. Oops. Let's put this and let's paste it here. And the flag RP. And this one, let's copy this and use register AXY and flag .name instead. So NES register flag does not have the init function for the name. So let's do that. View register flag. So let's copy the part of the name that is on register 8-bit. Let's do the same for 16-bit and do the same for register flag. And I guess we could do the same for bit flag. So that means that we always have to identify. Okay, so read it. So we are going to pass the p name in here. And make this assertion in here. Wait a second. And remove this init. And I am forgetting something very important, that is setting name equals pname. And that needs to happen for all the other inits as well. Now that we have that, the PC counter is meant to be registered with the PC name, and this is program counter.name equals to program counter. Okay. Cool. Now in the NES CPU, this is fixed, but this is broken, and that is because we are missing the part where we keep a name to all of this. So let's make that. Okay, and now all the flags have a name, has a name. Oh shit. Okay, I forgot a comma. Awesome. That was stupid. Well, the good news is everything is still working, and we can now start registering the missing part. So I want to check if maybe I can replace this bin for just a comma and pass the register and the addressing mode. So I am making a big bed in here. So we are now passing the name. Let's pass the name of the register. And now in the iteration later, we can say args or bind arg, which is gonna be an array. If instruction dot register not equal to string name, bind args equals no, pushback registers to instruction dot register. If instruction dot addressing mode not equals -1, bind args pushback instruction dot addressing mode. If bind args not is empty, if not is empty, instruction dot callback dot bind. There is a bind b, I think. Yes, bind b, awesome. And we can pass bind arguments. So now we have a way to turn this into something that where we can keep the register and addressing mode inside of the of the opcode. This one is going to take only the register A. This one, what? Oh, it was a comma. Oops, I did something wrong. Okay. This one, we want string name for the register and addressing mode as corresponds. So I should discover the first issue in here, and that is that now we have some flags. So now let's try if register dot has this, it's gonna add this, elif flag dot has, wait a second, right. So I suppose I will also need to have an array, but what was it? Flag register? The type? Yeah, bit flag. Bit flag. It's going to be a dictionary. And it's going to be equal to this sucker. Copy. I'm going to paste dot name colon and then each one of them. So now we can use flags.bit flag in our other instructions. What? Why is it typing down there? Bit flags. Dot has. Instruction dot register and it is going to push back flag bit flag instruction register is after false unknown register name, and let's put the name of the register. instruction.register. Okay. So important question. So we have AX, PC, AXYP, and PC. None of them is repeated, is it? No, seems not. That was important. Okay, awesome. So now we can continue making our registration. No op. Takes only 1 byte, so it needs nothing in here. Same here. And in our base CPU, break takes only 1. That is the only usage of opcode. Okay, so we can continue with our NES CPU. Where is our NES CPU, by the way? Did I close it? Okay, where did I stop? Yeah. So now we can put a comma, change it to oh damn. Actually, this one does not use addressing mode or register because we don't care of flags as far as I have seen. So we don't even need to track them. So let's forget about that idea. We don't even need this. But maybe we should have it. Yeah, for consistency I will keep this. And I will even keep this other one. That should not be necessary in any way. So so we can keep binding this one, and this one bit needs to be changed. Register a.name and spacing correct. This one uses flag, more flag. This one let's just move fast. We'll stop commenting absolutely everything I am doing. Hmm. I am a little burnt out, but I want to finish this before ending the stream. And I think I don't need this one. The thing with these ones is they are not reading memory, so we don't care that much. Okay, rotate is actually kind of important. Oh damn. So only addressing mode was important in first place. That was dumb, wasn't it? Well, I will not start concerning about that right now. What did I do wrong? Okay. It is missing a string name. Oof. This is a long list, just a couple more pages. Copy this. Will hopefully be easier. I mean faster. I just paste it without thinking too much. Okay, this one takes 2 registers. I will just not care about them because they don't read memory. The ones that we care are the ones that read memory. I don't even know if we care about the ones that write memory. So this one, damn. Okay, let's make this, pin this, string name, and then the argument. It's strange, but works. Because the pins go after. Oh, right. I will need to reorder this so it has the addressing mode before the mount. And now the binding is going to work because... Wait a second. I am making 2 binds. Can I do that? What happens if you call bind more than one? Maybe it works. I will know until I know. Okay, awesome. It does what I wanted. Okay, yes, it will bind the -1, and when it calls bind again, it will be added to the list of bound arguments. Now I can close this and put .name here. It will work. And this one, I want to remove the bind, put an empty string name, and then the addressing mode. I don't need this. We should keep it as is. This one I do need change. Oop. Okay. Let's see if this still works. Just testing the snake game. Okay. Expected 1 argument. So, question: does bind return a new callback, or it just changes? I think it returns a new callback. So what I need to do is in here, when making the bind, I am going to reassign the result. And what happens now? Okay, still same issue. Bind B returns another callable. And what is the instruction? Instruction is increase X, take 1. Okay, register is X. So where is in X? In X is binding the 1. Amount and then register. Cannot convert argument 1 from callable to integer. Why is callable? I did something wrong. So where is in X? Oh, match case. So let's put a breakpoint here. Wait a second, no. Arcs. So if instruction dot mnemonic equals init breakpoint. So what are we doing wrong? We got a registers has opened arcs is added the actual register. Addressing mode is -1, not empty, so callback is in pinned arcs using this callback. So what is wrong with you? The array is the register X. Indeed, it contains register X. I am going to make a pause for going to the bathroom. We're going to be back in just 1 second. Okay, I'm back. So I don't really know what is wrong with this. So it is assigning a callback, it's making a double binding. So what if I... Okay, oh, it's right to left, he said. Right to left or left to right? What was it? See in the description. When method is chained with other similar methods, the order in which argument list is modified is read from right to left. So we can make a test for this, quick test. So let's do this. Let's stop. Let's make a new scene. Making a node on it. Making a script. Built-in. Create. And in ready we are going to call function var f equals, it's going to be a function with x and y, and we are going to print x and y. So now we are going to try f.build 10.build 100 and call. Now this is just a matter of running this code. To do that we could try, for example, make it a 2. Do I have to save? Can I just leave and come back? Okay, I will need to save it. Save. Okay, what if I try enter 3 instead? Okay, I don't see it being printed here. What if I push error? Okay, I will just run it, I guess. So push error printed first the 100 and then the 10. And what if I use bind b and then put the 100 in parentheses? Okay, same result. So let's make a space in here just for readability. Oh, comma. Okay, 100 is added first. So what if we have x, y set and I call it with a 55? So we can have another space and then set. So we are binding 2 and call it with another one. What happens then? 55 goes to the start. Okay, interesting. So bindings are happening in opposite direction. So that means in our let's close this and delete the scene. Stop it. Thank you, you have helped. So now we have to check the cases where we have used bind and change our functions. Next CPU. So we have used in increase x increment register. It's going to take first the register and then the amount. Where else did we use bind? Okay, this one does not use both. This one does use both. So increment memory, we need to flip the order as well. And I think that is the last one. And let's hope this now works. Okay, we got it. We got the breakpoint. Okay, increment register callable. Cannot convert argument 1 from callable to object. Why is it trying to use callable? That is what I don't understand. Okay, let's try it like this. It's pinned addressing mode. Let's pin the register. Wait a second. Okay, it's correct. Still same issue. Why is it doing this? Why it's trying to call a callable? Why is binding a callable? It's still increase X or is another one? Oh, it's decrease X now. Okay, so now it is. This case. So yes, I suppose we can do this for being more consistent. Yes, we don't need two parentheses. Okay, game runs. Awesome. So we got into a state that is valid. Okay, I think we are going to commit an end for today. It's been a lot of progress, but it takes what it takes. Interesting, the apple can appear on top of your body. Uh-oh. Oh. Jeez. Woohoo! Oh, damn. This grows fast. Uh-oh. What is going on? I broke the game. I reached to some value in memory that was not meant to have a snake body on it. So basically a segmentation fault. Awesome. Anyway, this is running. So now we can continue our print. I kind of don't want to make that print. Duplicated code. if size bigger than argument index, return. Okay. Instruction. Right, it's instruction, not instruction set. So now I can just say dump my instruction. Instruction 1. Instruction 2. And forget about this. Now I dump memory access. Instruction. So this is out plus equal. And we make the dump. Func instruction opcode, and this should return a string, and we are going to match what was it, addressing mode, write this instruction, but addressing mode, and we are going to have all the addressing modes. So any other? Done. So before the memory dump, we wanted to print disassemble the instruction. So func dump disassemble, and we pass the instruction code the string as well, and we are also needing some stuff, I guess. String is going to be equal. So the last thing we have done in here, so we are going to dump the disassemble first. And let's see. Yes, I want to see the log. Here is the log. So it's one space, one space, one space, has an extra space. So let's see into that. So first, let's remove that space from this dump. Okay. Now I want to put that extra space in here. So I can reuse this part. So out is going to be a space, then a string that is going to be instruction dot. Okay, I'm going to have to return out. Oh, I am missing this operator. Mnemonic. So we have one space, the mnemonic, another space, and then we want the disassembly. So so basically this is going to be all part of the same. Return out, and this is just going to pass, and all of this I have to replace them for whatever is actually needed. So in the case of immediate, it is going to use out plus equal, and if I am not wrong, it will be a cardinal or hashtag, a dollar, then to instruction 2 to trim, so the thing with the trim is I want to remove the spaces. So this was it's missing instruction. Out plus equal this and this, and that should be the immediate, which is this case. So this one is reading. So because of that, 0 page is reading. So out is going to use $. Wait a second. So I also need to complete the rest of this. So okay, I will do that after. What is the full size of the selection? Doesn't show me, does it? So from here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. $34 characters. So before returning, let's do something very stupid. While out.length is less than 34, out plus equal empty space. Choose the dirty way. So now we can choose add stuff dynamically and it will complete. So for 0 page, we're going to dump the memory value, sorry, the byte, and then put an equal right to this 0 page and the value that is being read. So let's use this. So we need address. So how was the function for getting the memory address? Let's see in the NES room. No, sorry, NES CPU. I don't even see it here. The NES CPU. And the function for getting the memory address is get operand address. Memread. It is actually using program value. That is a little of a problem, but not that bad. Get operand address and then the operand, which is instruction dot addressing mode. So I guess we can make this out. So first we increase the program counter. Nope. get the operand, and decrease it again. Value is going to be equal to memory address. Okay, awesome. So now we should do it with value. Okay, that should be all for 0 page X. Sorry, 0 page. Now let's see 0 page X. Copy this and paste. And how is 0 page X written in the log? Set X. We need some mention of X. I think it's comma X without any parentheses. Can I search comma X? Load Y 33 X was 0 apparently. So yes, I think it's like this. So the difference is comma X, and this is more or less the same with comma Y. Absolute is going to take two instructions, first 2, then the 1, and nothing more. Absolute X I guess it is going to be like this. Dollars byte 2 byte 1 then comma X equals value. So I realized that we don't need to trim, because we already know from the addressing mode if we are going to have 1 or 2 arguments. So let's confirm absolute X is like this in our log file. Okay, I cannot open log from here. This one. Search.x again. This is indirect. zero page. Do we have absolute text? I assume yes. Okay, absolute X, yes, confirm it. So this looks correct. And so we are forgetting of this part. Are we? So for zero page X, we need this, but we also need the address. Address equals value. So this is address value. Okay. Okay, absolute X, absolute Y. Perfect. Indirect. So it's like this. So indirect takes 1 or 2 bytes. That's a good question. Okay. Indirect. Indirect should take only 1, isn't it? Because it's the, oh, maybe not. Give me a second. So let's just find more usages. So it is being used for jump. And in the case of indirect, it is reading 2 bytes from program counter. So yes, it takes 2 bytes. And that's end of question. Thank you. Search results. And everything uses the same notation. At address equals. Okay, so when there is indirection, oh damn. Okay, this is not as bad. but I will just need to do some stuff to find out how this works. So let's continue with this. So this is indirect x, and let's keep it as is for now. And indirect y, which is outside of the parentheses, if I remember correctly. So let's confirm that. So it's parentheses, comma, y. Yes, indeed. Oh, but indirect y takes only 1 byte. That's interesting. So indirect y takes only 1 byte. And how about indirect x? It's comma x parentheses. Yes, it takes only 1 byte as well. So only indirect take both. Um, okay, this is an indirect jump. Right, it was easier to choose search for jump. So this pointer, I suppose it means it jumped page. Anyway, so this was fun, but it's time for the end of the stream.